Hi all, this example builds the grid diagram for the application example number 15. We have performed the analysis in a prior example. You can remember some guidelines and building the grand composite curve and choosing the right engine. Then now we're gonna build the grid diagram. You have here the results. First of all, we have two pinches, a utility pinch for the hitting, touching the grand composite curve, this is the utility pinch, and the process pinch, the original pinch for the process streams. These two pinches define a three-region grid diagram with a hot side, a cold side, and a middle region. We will include in this diagram the minimum heating stream, the minimum cooling stream, and the process streams. For every stream we have the MCP and the total duty, the enthalpy flow, hot and cold stream, including heating and cooling. The first hot stream, the first process stream, goes from 150 to 40, exchanging 85 kilowatts. These start under the utility pinch, but over the process pinch, and goes down the process pinch. So it extends across the middle and the cold side, or cold region. The second hot stream, 95 to 95, creates the process pinch. This is at 95, and as a flat stream it can only be at a flat hot stream, it can only be on the cold side of the pinch. Then this crosses just the cold region. The third and last hot stream goes from 85 to 40, and this is all inside the cold side of the process pinch, the cold region. For the cold streams we have the reboiler divided in two chunks, in two streams. The first one goes from 150 to 190, and the second one is a flat stream at 190. The first one goes till the utility pinch, you see, inside the reboiler, and it doesn't arrive to the cold side. And the second one creates or start at the utility pinch, and is a flat stream that, as a cold flat stream, can only be in the hot side of the pinch. And the last cold stream is the feed, then goes from -6 to 115 Celsius. These start under the process pinch, crosses the cold side, and extends across the middle side, not arriving to the utility pinches. The same criteria are used to locate in the grid diagram the heating and the cooling, the utilities in general. The heating starts at 436 Celsius and finish at the minimum, the stack temperature, 124. Then this is going from over the utility pinch to under it, but not arriving to the process pinch, extending through the hot middle region. And the cooling starts at 20 and goes till 60. This is all inside the hot side. This is the naked grid diagram that never changes. Then on this grid diagram we will perform the design. For the moment, one thing we can do is represent the current solution, the process as is, on the grid diagram to see how the heat is transported across the pinches. This is the reason why the process is using now 384 kilowatts of heating, that is more than 275 the minimum heating, and 175 kilowatts of cooling, that is more than the 66.76 kilowatts that is the minimum heating, the minimum cooling. The excess is for both utilities 108.25 kilowatts. That represent more or less an excess of 60% of heating and of cooling. And this is all.